When an oceanic plate and continental plate collide, the thinner and more dense oceanic plate subducts under the thicker and less dense continental plate. This process is called subduction, where at the point the two plates collide, a trench is formed. This creates extreme pressure under the continental plate. This is due to the oceanic plate starting to melt under it, leading to magma trying to escape. This then causes volcanoes to form on the continental plate. A classic example of this is the Cascade Mountain Range, located on the western edge of the North American plate. Even though it is called a mountain range, it mostly consists of volcanoes. This mountain range spans 700 miles from British Columbia in Canada to Northern California. This range was formed over time when the denser Juan de Fuca plate subducted under the North American plate. This then created volcanoes on this area of the North American plate, with some of the most famous ones on the plate being Mount Hood and Mount Rainier. When two continental plates collide, they push against one another upwards. This is because they have the same density. This pushing causes mountains to form on the connection between the two plates. A great example of this is the Himalayas mountain range, located at the most northern western part of the Indian subcontinent. This mountain range contains some of the world's highest peaks, including the most well-known, Mount Everest. This mountain range formed 50 million years ago, when the Indian subcontinent broke off from Africa, crashing into the Eurasian plate. This collision caused the two continental plates to converge, creating the mountain range. When two oceanic plates collide, the older and more denser one sinks under the younger and less denser one. This then causes subduction, creating a trench where the 2 points collide. Volcanoes form on top of the younger oceanic plate because of the intense pressure from the melting of the older plate. This is due to the magma of the older plate needing an area to escape to. A good example of this would be the Marianas Trench, which is located 200 kilometers east of the Marianas Islands in the western Pacific Ocean. The trench is where the two oceanic plates collided and subducted, while the islands were formed due to the intense pressure under the younger plate due to the subduction. A plate boundary where two plates rub against one another, not creating or destroying crust, is called a transform plate boundary. A side effect of this is that it creates earthquakes. It is known for its displacement of surfaces like riverbeds, roads, and etc. A nice example of this would be the San Andreas Fault, which is located on the western edge of California, stretching roughly 750 miles. This transform plate boundary is still active, with it forming part of the tectonic plate boundary between the North American and Pacific plates. Hotspots are spots on the mantle that are heated up hotter than the others. This causes magma to erupt to the surface, going out through the weakest point. And when it cools, it forms volcanoes. Eventually, when the hotspot moves off the volcano via the plate moving, the volcano loses its fuel to keep forming and to combat weathering. So the weathering decreases its size heavily over time, leaving it much smaller than it was before. To clear any confusion, the hotspot stays in the same place, while the plate moves over it. This is shown by the subsequent volcanoes forming in the opposite direction the plate is moving, next to the originally formed volcanoes. A widely known example of this is the Hawaiian Islands, which is located in the northern area of the Pacific Ocean. The volcanic chain that has formed lasts roughly 6,200 kilometers, with the oldest ones being in the most northwestern part. So what we can infer from this is that the plate the hotspot rests on is moving southeast because of the oldest volcanoes that are located northwest. A divergent plate boundary is when convection currents inside the Earth pull two plates away from one another. When two plates diverge, they cause rift valleys on the surface, which are gaps between the plates, usually filled in with ocean water. With two oceanic plates, however, the rift valley turns into an ocean ridge. A rift valley is a linear depression that forms when two plates are diverging, often leaving lakes and steep cliffs on either side of the divergent boundary. This can occur on both land and sea, but when this occurs on the ocean floor, it leads to the formation of an ocean ridge. An example of this is the Great Rift Valley in northeast Africa. More specifically, it stretches 6,500 kilometers from the Middle East to Mozambique, with it being formed by the Nubian and Somali continental plates moving away from one another. This divergence splits East Africa apart, creating a series of deep and continuous depressions, as well as lakes and volcanoes. An ocean ridge is a mountain range formed on the seafloor when two oceanic plates start to diverge. As these plates diverge, molten magma shoots up in between them, creating new rock and introducing a process known as seafloor spreading, in which a new oceanic crust is added to the sides of the oceanic plates that are separating from one another. This process leads to the oldest oceanic crust to be the farthest from the ridge, while the youngest is the closest. A really good example of this is the Mid-Atlantic Ridge, which is a 10,000-mile-long underwater mountain range running north to south through the Atlantic Ocean, with its shape paralleling the continents while being in the middle of them. This divergence separates the Atlantic Ocean from its eastern and western parts, while adding oceanic crust to each plate through seafloor spreading. The plates that are separating from one another are the North and South American plates on the western side, from the Eurasian and African plates on the eastern side.
Thank you for watching.